2 responses, okay, or 2 calculations. Okay. So, this is dependent sample because the samples are linked, both samples are linked, samples of this, and this is independent sample. Okay, and we will see demonstration of this right now. So, let us import our data, import our format file which we have in the download folders, that is what I assume, school 1. Okay. Submit, we have talked about it multiple times. This is our data. Now, we are trying to say there are categories, please understand. Let us see the category age, or let us see the gender category. Yeah, gender 1 1 1 0 1 0 1 0 1 0 1 0 1 0. Okay. So, there are 2 categories. Now, these are factors. So, we make it factor, okay, and you see because why factor, because 1 and 2 are numbers, not names, not okay. Now, we go here and we go to parametric test, we go for means and we go for comparing means for 2 independent samples. Please see the word. And we are comparing it to gender. I think this factorization create a problem. We are writing 1 2 1 2. Ideally, we should write, okay, let us take age 3 group, means of 2 paired independent. Okay. Now, so we have comparing the means of CSC underscore 1, we can take JP1 also, not an issue, according to age 2 category, which is having 2 levels 1 and 2, which is coming here. Now, comparing populations. So, I am comparing 1 with 2 or 2 with 1, that is important and we will see how, because the ordering is important, the test. Okay. Now, we press submit. Now, you see population 1 and 2. Now, population 1 is not dash 1, it is the first one. Okay. So, we assume the first one is first, if we were reverse it, otherwise it could have been different. So, there are 2 populations. How? The complete data is, if you see around 590, we have reduced 590, then okay, the degrees of freedom are, so 5 out of 590 we will see this. So, we can see this here how. We will see here by means the descriptive means parameters, no, in just a second, we will, yeah, starts, sorry. So, we will have this plot by groups, okay. So, these are the means of group 1 and group 2. Now, again let us do it. This was the graph and let us see the quality of the descriptive statistics, CS1, statistics by group, age, okay, mean, where is the mean word, mean, arithmetic mean, okay. Okay, please see here, this is a problem. This is what happens, gender should work. Okay, editor, please remove this. So, what we are trying to say is 309 entries are there and 279 entries are there, and these two are differently differently affecting or not affecting. Now, first test is comparing the means. If you remember, we did discuss there are 3 conditions. It has to be normally distributed, okay, and the sample variations should be equal, okay, or obviously independent sample, the sample variance should be equal. Now that is what is the assumptions being checked here. So again, so as the p value is 0.19, please see here, as the p value is 0.19, the hypothesis is of F test is of comparing variance that the two variants are equal. Now the p value is less than more than 0.05, which means we fail to reject the null hypothesis, we accept the null hypothesis, we assume they are same, hence we say that they are of equal variance and hence we are testing it here. So now the p value come at 0.008, which actually means that at 0.05 level the difference does not exist, at 0.10 level the difference exists, okay. Why did I say that? Because the p value is 0.891. See, p value is 891, confidence level is 95. Now does this interval contain 0? The confidence interval which we are talking about is minus 0.272001. So there is 0 in between. So at 95%, we say they are same, because 0 is contained, the null hypothesis value mu minus u2. What is the hypothesis, what is the null hypothesis of independent sample test? That mu1 minus mu2 is equal to 0, and that we can check here also. See, mean of this is this, or mu1 minus mu2 is equal to 0, okay. Hence we find out. Now at 95% we are saying they are same. Now what happened 90%? Let's run it again. Now you see at 90% what's happening, the range has changed. What has it become? Minus 0.249 to minus 0.004. This does not contain 0, 0 is here. Hence they are different at 90% confidence. As you can see, at one point we say they are same but 95%, and another point we are saying they are different at 90%. Okay, so this percentage level will change your answer, as in the previous case where we were trying to say mean of 23, 22 we were testing. Okay, so please understand this. Now this is very important, please pay heed here. This F test for comparing means is very important, because after the means, generally we assume the means are equal, so we want the test to fail or p value to be more than 0.05. If they are unequal, then we go for the first table. Okay, we go for the first table. Now please see, if you remember, we will explain this to you, that how all these values comes as what is degree of freedom and what is F statistics. This we will explain in the ANOVA class, okay, that how to get an F table, F value. So sum of square, two groups are there, sum of square and everything, we will do that SS, sum of squares, of errors, okay, total, within group, between group, everything we will do. So, please understand, when you just have to compare two tests, two variables, sorry, one variable with two groups, then you go for an independent sample. Now, you have looked it here, okay. Now, we will go for another test called the paired sample t-test. Now, why it is called paired sample t-test? As I told you, one sample, one respondent is active in both the readings in the pair, okay. Now, please see here, how do we have to either create the data or we have to load a data. So, let us create a data. So, as we told you, there are two levels only, score of group 1 treatment 1, I have pressed the scroll log somewhere, yeah, and treatment 2, okay. So, let us say treatment 1 I get value of 3, 2, 3, 4, 5, 1, okay, and in treatment 2 I got 2.2, 2.8, 4.1, 4.9 and let us say 2, okay. So, this is our data. We have taken 5 respondents. 5 respondents responded to treatment 1 and treatment 2 or test 1, test 2, whatever you want to say, condition 1, condition 2, and we have got the data, okay. Let us save it, okay. Now, we will import it. Let us see if the import happens. Let us cancel this out, let's cancel this out. We will import the data from this, okay. And now, this is what we have to go, t-test pair data. Again, see, please see, if the preview does not come, that means there is some issue with the file. Okay, let us try again. The file has some issues, no problem. We copy this file. Okay. See what was happening? There was a overlap of the variable name. Hence, the object was, because we already have created mycsv.data. So, now we can read the earlier file also. This is t-test paired, okay, numeric, submit. Now, this will be created in a separate tab. See here, workspace, mycsv.dat, .dat is the file, okay. Now, here we go and we go for parametric test, we go for means and we go for paired population, compare treatment 1 with treatment 2 and let us say they are equal, or whatever it is, okay. See, here also again you see that 0 is contained, okay, hence they are not different, or the p values more than 0.05, hence they are not different, because now let us check what happens if we run it again. Let us say at 65%, what happens? 0.65. See, at 65 also it is still containing 0, but as we decrease it, it will change. Let us say 45%. 40%. See, 40%, the confidence interval is, is very similar. Let's check it again, what has happened here. Why did it become 0.5? Yeah. Now you see, 0 is not in between. Okay? 0 is not yet between. Now, we do not have to compare the p value with 0.05, but we have to compare with 0.5, and at 0.5 it is less than 0.399, it is 0.399 is less than 0.5. 0.05 is for the confidence interval of confidence level of 95%. We are 50% sure that they are different, and I hope I will be always very frank with you. This should work at 60% also. See, the p value, as I told you, the p value will not change, the statistic will not change, it is your benchmark which is changing. So, the change is happening on the rightmost columns. So, here I by mistake I entered 0, here I entered 50. So, okay, 0.4 is the error, 0.4 is the error, not 6, okay. 0.4, so 0.399, you can check it if I say 65. When I did 65, it included 0. So, we are 60 to 62% sure that this is a, okay, or very simple thing is take the p value, subtract it from 1, that much sure you are. P value is minus 1.39167, so you say, okay, I will take the value of let us say 0.61%, okay. So, 1 minus p value, whatever p value it is coming is actually your confidence level, the data is speaking. Now, for you to accept or reject, you have to check your significance level. So, p value is the probability of error of type 1, okay. So, the probability will not change. Your benchmark of accepting that level or not will change. The cutoff will change, not the marks. So, confidence interval is the cutoff level we decide. So, at 1.4, okay, around 0.6 difference or 0.4 error, we can say these are different, but at 95 we cannot say that. At 95 we cannot say it. So, these are the two tests primarily are very important. These are 3 tests we have discussed today. Okay. So, t test, now please see the observation which we are trying to say. Okay. In paired t test, each sample minus 2, because n minus 1 is group 1, n minus 2 is group 2, combine both of them, that is n minus 2. Now, there is only one sample here because actually it is one sample. So, n minus 1. Okay. What is n? N is number of one respondent, not the complete entries. Okay, it is n minus 1. So, n here is 5, so it is 4. Okay. So, now as you can see the examples here, there is nothing to elaborate, but things are very similar. Mean difference in heart rate of a group before and after exercise. So, treatment 1, treatment 2. Treatment 1 is no exercise, treatment 2 is some exercise. Okay. Mean heart rates of 2 groups. So, this is very important. As I told you, subjects might differ. Subjects are differing. Okay. On that base, we have 2 sample tests, same thing. Okay. Now, if you see, we clicked here something called parametric test, and I wanted to touch that also. Parametric tests and non-parametric tests are different. So, there are some assumptions of parametric test. Okay. That first of all, a dependent variable is scalar or ratio. Okay. Now, what does it mean? Dependent variable, the y which we are always analysis of variance, we will go talk tomorrow or later, or we have talked about the dependent variable in the t test. That is again what we say a number. Okay. So, if it is a number, not number as a name, number as a scalar data, okay, scalar or interval. then we call it as a interval or ratio data. If the dependent variable is nominal or ordinal, we take a non-parametric test. Okay. There is no randomization. If you have properly selected them, then it is again a chi-square test. It is not a, it's again a non-parametric test, not a parametric test, because randomization is very important. What does randomization mean? If you remember, we discussed the technique of sampling. So that is one thing. You are not having a predefined logic that let's take these three, then these three, then these three. Okay, that is not randomization. Okay, and the shape of in population of interest approximately normal. We will discuss more about this normality test when we are trying to talk about the regression coefficients. Okay, now so please understand here we have more or less discussed things. There are some things which we will discuss about test, which we will talk about later. I will just introduce the terms because now we are going into analysis. Tomorrow, after some time, we will cover ANOVA. Now, what we are trying to do, हम लोग क्या करने की कोशिश कर रहे हैं? What we are trying to do? We are trying to understand the application of test. Now, generally, just p value is asked. Okay, and if the p value is less than 0.05, you say we reject it. Otherwise, please see, having statistical difference does not mean the difference is large. But difference is there. So 19.1 and 19.01 are different. So that 19.02. But is the 19.01 and 19.02 different? Please understand, people do this mistake. They try to call this as significant. There is no significant difference. No. Significant difference is not about the size of effect. Okay? It is about the population thing, that is it different or not. Now, the effect size is trying to measure the actual difference, how much is the difference. If two samples are saying, okay, math scores of girls and boys are different in state A and state B, and we get that there are difference, we do the t-test, we get a difference. Now, what does it mean? How much is the difference? We cannot say that. We cannot say that. Okay? For that, we have to go for effect size, and we will talk about this later, because gradually smaller steps will be taken. We will cover this. Okay? And similarly, this. What is the power of test? This is 1 minus type 2 error. Okay. So now this is very important for us to understand. We also have to understand why one tail test and two tail tests are important. As you do remember that we try to understand. Let's show you. This is a two-tail test where you are interested in finding the values. It's a one-tail test because the two-tail test because it is both directional, bidirectional, and where the alternate hypothesis they are not equal. But if the hypothesis is it is less than or equal to, please see that. That is what we have. Please check it here. Let's check it here. Test option. This will call a different story. Okay. This will talk a different story. See, just by changing the options, I get different result. Okay. So, minus 2 to infinity, that was one thing. The moment I said it is bidirectional, it is different, and if I make it otherwise, see, at one point it is this. So, minus 2 is here also. Okay. Minus 2 is here also. Minus 0.3 is here also. Minus 0.3 is here also. Okay. Minus 0.3. 439. So, in that way this is very important, one tail test, two tail test. So, if it is just 95%, this one 95%, if you are testing this side only, then we have only 5%. If you are testing this side to be 5%, then we are getting 95% for the T statistic. Okay? T critical levels. Please see the T statistic value is same in all cases. As I told you, if you change your confidence, things will change like this. Okay? So, with that we end today, and now we will discuss ANOVA next class. Thank you very much.